seems to be my year for the tech moments. All right, are we ready to go? Everybody here to learn about Hubble? Yeah. All right, thank you. Well, I want to thank you guys for coming. I know it's middle of the afternoon, Sunday, we're all kind of dragging a little bit, but, well, I don't know about you, man. I was going to go to the costume contest last night. I went up to my room to lay down for a half an hour at 7 o'clock, woke up at 11:30. How many of you came to Alan's talk yesterday? Oh, good, thank you. All right, so I need to have the cell phones turned down, please, or whatever's playing.
That's the dude. That's the guy out.
Oh, I'm sorry, never mind. Okay. Somebody close the door, please. Well, Alan was so... All right, I'm going to have somebody up here with a bow and arrow. That guy was... Oh, thank you. All right, so Alan was very pleased yesterday. I got an email from him. He was sitting at the airport waiting for his flight, and he was so thrilled with this that he said he would love to come back, and so we'll try to get him back next year to talk about what they found on Pluto. And next year, they'll be about halfway through the data download of all of the Pluto information, so he'll have quite a bit to show us. And this is all, of course, depending on his schedule, but we'll see what we can do. Also, if you're interested in having more science talks, do let the con organizers know. I'm happy to pull people in here as long as we can get a nice room or even fill up part of the main events. And if you have suggestions about what you'd like to hear about, let them know and they'll forward that to me. So, if you don't know me, most of you do, I'm Carolyn Collins Peterson, and I'm a science writer specializing in astronomy and space science. And when I was in school, well, let me go back a little bit. I decided to go back to graduate school in the late 1980s, and I thought I was going to study Mars, because I was really into Mars. Still I'm into Mars. And I got to graduate school, and well, before I got there, I had to take a bunch of makeup classes. So I studied astronomy for 3 years and chemistry and biology. And then about the time that I decided to apply for graduate school in astrophysics, NASA cut the funding for as many graduate students as they've been doing, so I couldn't get in. So my boss said, well, and I've been working on a bunch of stuff where I had a job at the university, and he said, well, we don't want to lose you, so I will pay for any graduate program you want to take. You just can't take astrophysics. We don't have any room. So they went from 21 students in the first year to 6. And so I thought, okay, I can still take the classes, but I want to study other things. So I went around and I talked to the people in engineering, and I ended up doing a double major in telecommunications engineering, which I thought would help with radio astronomy, and it does. And then because I was already making a fairly decent living as a writer, I studied journalism, and science journalism in particular. So my thesis was on the media treatment of the Hubble Space Telescope, what happened to Hubble after it launched and how the media treated it for the first few years. So in the middle of that time, I was actually coming to Starfest. I think there was a StarCon and a Starfest. Yeah. All right, so I was doing those twice a year. I was coming in. And Kevin Atkins is an old friend of my husband's and mine. We've known each other since we were practically in the egg together. And he said, well, why don't you come and talk about some of the cool science you're doing? So I think the first talk I came and gave was about, I think it was about Hubble, but I can't remember now. Is this going to work? Oh, come on. Well, I guess I'm going to have to do the routine. Oh, I see what it's trying to do. A little introduction. There we go. So, my first Starfest was back in the Jurassic period, and it was still being held over on I-25 in that dome building and all that. So, and I was just totally blown away. I mean, this is just more geeky stuff that I love, and I went and I gave this talk. Well, it was my first ever talk at a Star Trek convention, and I was actually pretty nervous. I just didn't. I really wanted to do well for Steve and Kathy, and I wanted Kevin to be proud of me, and I didn't want to forget my words. And I didn't want to spill my slide tray because we were running around with slide trays all the time. And I remember I was standing off stage there was this big auditorium, and I looked out and the whole place was filled except for this front row. The front row was completely empty. And I stepped up to the podium, and just as I did, this whole troop of fully dressed, babble-laden Klingons walked in the door, came down and just sat like this and looked at me. And so, what can I do, right? So I did what any other lecturer would do. I basically said, kapla. And they all yelled kapla back, and we had a good time. Well, they were mostly harmless. They did throw mugs of blood wine at me when I was done, so I guess I did okay. And I learned a few other things about Klingons that were quite interesting, but I digress. I can't put that picture up for too long in case there's kids in here. But anyway, it was a great time, and then the next year, a couple of years later, so I was doing talks about comets at that time, and then the Hubble Space Telescope launched in 1990. And so then I started doing talks about Hubble Space Telescope, and that's what I'm going to do here today. So today, starting on the 26th, is the 25th anniversary of the launch of the Hubble Space Telescope. And I had just started graduate school right before that in this great compromise where I couldn't do astrophysics, but I could do all kinds of other things. So I was out doing cool engineering stuff. And I was working with Dr. Jack Brandt, who was the head of the Goddard High Resolution Spectrograph team, which is one of the instruments that was on board Hubble. And he took us all in, I think launch was in April, so about February, he had to move to the East Coast, just as Alan has to do for his launch. He's got to be out there for 6 months. Jack moved to the East Coast and he said, okay, I'm depending on all of you, my students, to do good works and don't make me unproud and all this kind of stuff. But he also sat down and said, you're not allowed to talk to the press for the next 6 weeks. And this was about 2 weeks before launch, or something like that. So he told us all about what launch was going to be like, and we couldn't go to launch. It was kind of restricted how many people could go. But he told us it's going to be the ride of a lifetime. This is going to be great. So the thing launches, and to give you a little background, when you're on a mission, launch is the most heart-stopping moment of your life. So I mean, you probably, if you were here for Alan's talk, you saw that launch of his spacecraft going like a bat out of hell up off the pad. Well, ours was launched on board the shuttle, and we were already nervous enough because of the Challenger mission. The Challenger mission had delayed the deployment of Hubble Space Telescope by several years. So we're all watching this launch on television or wherever we were, and we're just like, nothing can go wrong. And just before that, we'd had a group of people on the Mars Observer mission who, at the University of Colorado, and their spacecraft blew up when it got to Mars. We don't quite know what happened, we think we do. And it was like grieving. I mean, there were people on that team who were just pale and crying. It was like you lost your child. You know, Alan said they spent 10 years on this. Jack Brandt spent about 25 years of his career on Hubble. I've spent about 25 years following Hubble on my career. And they become like your children. You know, I don't think of Hubble as this thing that's out in space. It's this baby we worked on. And I think Alan's the same way. You know, he's very proud of it. Every person who has a spacecraft is like that, and they get very excited about it. So we were scared to death that this thing wasn't going to get up there. And when it did, we were very thrilled. Well, we started getting pictures back, and they started looking really weird. And they weren't sure what this was, so let me explain it a little bit. This is what's called a point spread function image. The picture of a normal star would not have all this crud around it. So what had happened was they're looking at this and they're saying, something's wrong. Why isn't all the light from the star circled around it? Why isn't it right in this point in the middle? I'm going to turn the lights on so you can see. Sorry about that. So why isn't the light all concentrated in the middle? And everybody thought about it. They thought about it. There was a 6-week period where we're getting weirder and weirder pictures out. And every one of them had this light spread out like this. So we just called it the point spread function problem. And we really should have been seeing point light stars. So this is just a star. There was a meeting in, I believe it was June of that year. So this Hubble launched in April 26th. We started seeing weird pictures, and at first they said, well, it's not calibrated, we'll focus it. And they did all that stuff. We're still seeing crap all around the pictures, all around the point sources. So one of the scientists, whose name is Sandy Faber, stood up in a meeting at Goddard or wherever they were, and she said, well, this really looks like spherical aberration. And it was like, you could hear a pin drop in the room. Nobody wanted to believe this. No engineer wanted to hear this. No mirror grinder wanted to hear this. But that's what it turned out to be. It's called spherical aberration. So we had this soft blur all around the images. Once we understood what that was, that pretty much sent shockwaves through the community. Now you have to really understand the backdrop of this. Hubble had just been launched, $1.5 billion to get this thing built and up into the sky. So we had scientists screaming, oh my God, we wasted all this money on Hubble, we could have been putting it in planetary science or geology or whatever. You had politicians just screeching. Barbara Mikulski of Maryland was the biggest critic. And she came online and said, this thing's a techno-turkey. To give you an idea, 25 years later, there's a library named after her. She became the largest supporter of Hubble because we were able to fix it. Politicians are like that. Be careful about your friends, they may become your enemies, or the other way around. Well, this caused a lot of anguish cries from everybody. So how could we spend $1.5 billion and get this? We weren't really sure. It was a disaster. And we found out later that what happened was that the mirror was ground precisely wrong. And it was wrong at a level of round off just a little bit too much glass. It was the thickness of a human hair. And that was what basically caused all this stuff to happen. Well, of course, we had to regroup. The summer of 1990 was pretty awful. We weren't allowed to talk to the press. We had people calling. They found out our office number of the student offices, and we just had to say no comment. And normally we like to talk about our science, so this was a bit of a problem. The telescope was still up there taking images. You know, we're all griping on the ground about this thing, and yet it's up there just clicking away and doing its thing. Turned out the faint object spectrograph, its science was pretty much dead in the water. It could not do any science, or very little. Our instrument was affected not as badly. The cameras were not affected badly, but we were getting this kind of stuff. So this is taken in, I would think it was like August or something like that. This is supernova 1987A. Here's a star that blew up. There's a cloud of material coming off of it. Here's a ring of material that was blown off the star before it blew up. So this blew up in 1987, and we looked at it in 1990. So they were actually able to look at this. This is cleaned up of spherical aberration. You can see a little bit of it left here. They cleaned up as much as they could here. And the way that we did that was we did things called, we applied mathematical solutions to the images. It's a process called deconvolution. And there were some other processes, but it basically, they characterized what this was, what this point spread function was, and they built code to basically computerize taking it out. So we took out the spherical aberration as much as we could, and then left in the material that we thought we could look at. So we were able to look at this thing. This star is about 170,000 light years away from us, and Hubble would let us look at the expanding ring of material. So it was considered, that's pretty successful. At the same time, we still had the press going, this thing sucks, it's not working, we spent $1.5 billion. You know, why are you people wasting your time? And the scientists are quietly working away under a firestorm, you know, of criticism about this. We had Barbara Mikulski out there and various other people. And people like scientist John Bacall, who was one of the biggest cheerleaders for the program, went on the warpath and went out and told everybody, look, we're still working this out, we're smart, we're from NASA, we can figure this out. And they did. They eventually figured out a way to fix it. This is another image that was taken later that year. You could not get this image from Earth any other way. I mean, this is something that you would see from a spacecraft flying around Saturn. These are just little storms in the upper atmosphere of Saturn. So we were getting lots of data, we were working on it, we were quietly doing it. At the same time, I was starting to take lots of notes because I kept thinking, here's an opportunity, I might be able to write a book about this, or maybe my master's thesis or something like that. But people at the same time were putting their heads together and coming up with ways to correct the Hubble's vision. So a couple years later, they came up with something called COSTAR, which is Corrective Optics Space Telescope Axial, I forgot what R stands for, repair. And the lenses for that were grounded at Ball Aerospace in Denver. Well, they were grounded at Tinsley and then brought to Ball. Ball put together essentially the contact lens kit for the space telescope. And then some of the instruments that went up, like WIFPIC 2, which is a wide field planetary camera, had their own built-in corrective optics. Every instrument that's gone up since then has had its own optics to fix it. So the mirror is still sitting there whacked out. There's nothing you can do about that. But we've been able to put corrective optics to fix each of the instruments that goes up. But we didn't really have to wait until 1992 to get good images. HST started turning out good usable science the first year. It's just that nobody knew about it. I knew it, the public didn't know it. I would go out and give talks like at Starfest, and people would ask me, so what is it about this thing? Is it working? And I only had about 5 objects to talk about at the time. So they were really short talks. I would talk about other things. But it was just taking us longer to tease out the really good images. And it was frustrating to know that nobody knew about this. Well, after about 1.5 years, we had enough good images. I started writing my book, and it was called Hubble Vision. I think you can still get this used on eBay or Amazon or someplace. And I was working on it, and I asked Jack Brand if he would like to read the manuscript, and he did. And he said, okay, and he made some science tweaks and some other suggestions. So I finally said, do you want to be second author on this? And he said, yes, I would, because you still have to be the first author. So we published this. We put it out for bid. And Cambridge University Press just jumped on it because they're a big scientific institution. They wanted something that was positive about science. So I also did a planetarium show about, I did a second book called Visions of the Cosmos, where we talked about this Hubble science and other science. We both did it. I worked on a little documentary called Hubble Report from Orbit, which in 1992 won an award for talking about that kind of thing. Oh, there we go. And then we did a planetarium show called Hubble Vision, which we actually still sell. So a lot of what I do in terms of science communication is writing, but we also, my husband and I produce documentaries about this. So is a telescope worth loving? really. I mean, in those early days, we thought, oh, it's a techno turkey. I mean, some of us did have our doubts. Are we going to fix this thing? But we got it to work, and so 25 years later, we have all this wonderful science coming out of it. So I want to talk a little bit about some of the images that have come out from it. And I kind of wanted to do it from a little bit of a Star Trek twist, since I was a Trekkie from way back. And one of the things that I noticed, I don't know if you noticed this, after a few years, images from Hubble started showing up in the Star Trek shows. So in astrometrics and places like that. Well, this is one of the images that they used in astrometric. You know, I did go back and try to get screen grabs of these things. They just look awful, so I actually just went and cut the Hubble images. Well, you know, it was in the background, it was on the screen. But I remember a friend, a friend of mine is Andre Bormanis, and he worked on the show. He took me on a tour, and he told me, well, you know, it was my idea, or I suggested some of these images. They needed something for the backdrops. So they went out and found images like this and put them up. And so like in Voyager, I think you see 7 of 9 working in astrometrics. She's got some of these pictures up in the background. Well, this is a star-birth region, and one of the things that Hubble has been designed to look at is dim and distant objects that are far away, and or looking at very high resolution of things that are fairly close to us. This is kind of a dim and distant object. You can see parts of it maybe with a naked eye here in a really good dark sky sight. This is in the summertime sky for us. And it's called the Trifid Nebula. And Hubble was actually able to zoom in on the center of this thing. So this is the very center of this star-forming region right in here, right in here. These are hot young stars that have been formed already. They're eating away. They have radiation coming off, and they're eating away at the clouds of gas and dust. So we found a lot of this. Hubble is a star-birth region discoverer. This is about 9,000 light years away from us. This is in the constellation Sagittarius. Oh, that's interesting. They also used HST images of the Orion Nebula on Star Trek, and this is really famous. I mean, it's been all over the place. It's on covers of books, but this showed up on, not this exact picture, but one of them, the versions showed up on Star Trek. Hubble was actually able to zoom in with various pictures. There's a lot going on in this image. So there's star birth going on in these dark regions. Here's 4 bright little stars called the trapezium. It's 4 little stars there. They're fairly newborn. They're hot, they're bright. They've got a lot of ultraviolet light coming off of them. And ultraviolet has this interesting property that it dissociates. It tears apart atoms of gas inside of a cloud. So you see it kind of eating away. You can see it kind of eating away at the cloud of gas and dust. It's also causing it to glow as well. So this is the kind of the nearest star birth region that we have to us. It's about 1,500 light years away. This particular image took 105 Hubble orbits to take. Every imaging instrument on board had a piece of this. The Advanced Camera for Surveys, the Wide Field Planetary Camera 2, near-infrared camera. Near-infrared is very interesting for looking at things that are warm. And these stars warm up their clouds of gas and dust. So these were all used to simultaneously make this image. It's just probably one of the most stunning things I've ever seen come out of Hubble. Now you may have seen this one before. This is also used on Star Trek. It's nicknamed the Pillars of Creation. It's in the Eagle Nebula. And what's going on in here is there's a little star, they think there's a little star being born in here, some stars. You see little jets of material coming out. The discussion is whether or not those are coming out from stars or not. But there's a star that's off the picture here, and it's what's eating away at these pillars and forming them. It's basically killing off all of the gas and dust that's used to form these stars. It's kind of an interesting thing. You get newborn stars, and they basically choke off the food for their younger brothers and sisters. It's kind of a cannibalistic way of star birth. So these especially dense clouds of molecular hydrogen, that's really what they are. 2 atoms of hydrogen in each molecule. These have survived quite a long time, but this star is actually eating away at them. So they call this photodissociation or photo evaporation. And you see this, if you see this in a nebula, you're pretty certain that there's been some kind of star forming activity going on. Oh, come on. Oh, I'm sorry, did I? I'm being stymied here. Ah, here we go. So this is just a close-up. It's the Voyager, I think this showed up on Voyager a couple of times as well. The only reason I zoomed in on this is I wanted to show you these little features here, that there could be a little star forming at the tip of that. This looks like it could be a jet coming out. Again, if we look at these with infrared, with deeper infrared, we probably see a lot more activity going on. So astronomers are really fascinated with this one. This is, in fact, an ultraviolet view. Or this is I'm sorry, it's an optical and ultraviolet view, but if you look at a deep ultraviolet view, get rid of all the stars and the cloud of gas and dust, here's a little star forming and here's little jets coming out. So once you can see through that cloud, and essentially that's what the infrared kind of lets you do, is see through the cloud, you can see what's happening in the middle of these stars. So we have star birth, which is a pretty destructive activity despite the fact that stars are being born. Here's another one that shows these little stars are eating away this cloud of gas and dust. There could be stars being formed here, but it's just as likely that these will just choke off the amount of food that these guys need to be born. This actually picture, I really like this one. It has a cool little galaxy right here. It's really not part of that. It's way distant, but I was looking at it thinking, well, here's one, here's a little star cluster over here. There's really a lot going on in this image. These are all images that were used in Star Trek. So the Voyagers folks also used images of stars dying, and I think I saw a couple in Star Trek The Next Generation too. And people do always ask me what's going to happen when the sun dies. This is an image I took off the coast of New Caledonia a few years ago, this gorgeous sunset. And those are the times when I usually sit there on the ship and think, oh, well, what's going to happen when this thing dies? And you can just see it getting bigger and bigger and bigger as it swells up, which will happen in about 5 billion years, so not a big rush here. But it'll swell up and it will basically eat up our planet, and that will be sort of the end of our star. But what does it look like when sunlight, planets, or stars die? Is it going to come up? Ah, here we go. So it could look like this. Now this is actually probably two stars, and one is the sun-like star and it's dying in the middle. When our star starts to die, it's going to start swelling up and become a red giant. It will puff off as outer atmosphere to space, and there will be this cloud of gas and dust. If there are two stars here and they're spinning quickly, it may form what looks like a bipolar jet here. So I think the thinking here is that there are two stars in here, two outflows. This is called M29, and it was actually used in an episode of Voyager called Alice, which unfortunately I never saw it. Did anybody see it? Yeah, I don't know either. It's kind of pretty though. This is another one that they showed in Voyager and on TNG a couple of times. It's called the Ring Nebula. You probably can't see it now, but later this fall you can take a look at it. It's something you have to have with a small telescope to be able to see it, but it's something that you can find. It's a wintertime object. It lies about 2,300 light years away from us. The dying star is right in the center here, and all of this is material that got puffed off as the star was starting to age, and it's now expanding out. It's like you're kind of looking down a barrel. This is really a spherical object, but you're looking down through the center of it. Hubble captured this view. One of the things that they've done is look at it a few times. This wasn't in Voyager, but this is called the Helix Nebula, a similar type star up to the sun died. Here's what's left of it. This is a white dwarf, so that's what our star will become, is a white dwarf. And this is actually kind of interesting. This is a composite of, is it going to come up? Okay, this is a composite of Hubble images and ground-based spectroscopy. Spectroscopy is a process whereby you can look at the light coming from a star and you can tell how distant things are from you and how quickly it's moving. So this is a 3D model of what this helix would look like if you could look at it from the side. So it's actually kind of cool. You can see really fine webs of filamentary objects here. We call these cometary objects. They're not comets, but they just look like comets. So what we're really looking down is a 1 trillion mile long tunnel of gas. There's a gas here, but there's a 1 trillion mile long tunnel in this spherical object. So this is the top of it, and then the other side of it would be down here. And all these gases are fluorescing from the heat of the white dwarf. Oh, it's coming back. Here we go. This is one of my favorites. This is the Bubble Nebula, and it was used in the episode called Unimatrix Zero. And this is an expanding shell of very hot gases from a star, and it looks like it's about to collide with this material here. And when it does, there'll be all kinds of fireworks. It'll be a kind of a shock front moving, and it'll hit this thing, and all of this gases will glow. So it'll be kind of pretty bright in a few thousand years. And of course, the famous Cat's Eye Nebula. I have cats. I don't know how many of you guys have cats, or even cats on me. But anyway, we took the Cat's Eye Nebula and put that on the cover of our book. And it showed up in Voyager. It's on the cover of my book. It is, all of these things I've been showing you are what are called planetary nebulae. And that's what happens when a sun-like, that's what it's called when a sun-like star dies. But this is actually pretty cool. There's some thought there's a second star in here as well that's kind of whipping up the cloud and causing it to have this very complex shape. course, there are other images from HST that have made a really big public impression. This is a mosaic image that was taken with the Space Telescope, and it's called the Crab Nebula. The Crab is a supernova remnant. So stars the size of our sun die and they become planetary nebulae. Stars that are 7 to 40 or so or bigger times the mass of the sun explode as supernovae for the most part. And this is what's left over. So the actual center of the, oh, I can't see it from here, but the central star is in here somewhere. And it's actually spinning about 30 times a second, sending out a little pulse of light, a little pulse of radio waves. And that was detected in the mid-1960s, and they named it a pulsar. So it's like a pulsing object, so it's called a pulsar. It's discovered, I think this is what Dame Jocelyn Bell discovered. So, and they can still track this. It's still spinning around like a little clock. And this is all material that's come out from the star and is spreading out to interstellar space. And incidentally, stars, when they spread their material out, are spreading newly formed elements, you know, heavier than hydrogen. You've got carbon and nitrogen and oxygen. And in the case of these guys, it's going to be gold and plutonium and lead and whatever else. This is all being spread out to space. A few billion years from now, that's going to be material that can be used to form planets around other stars. Here's another view of this. I really like this one. It's several different wavelengths of light: X-ray, visible light, infrared, and it just shows some more structure in the Crab Nebula. This is where the star is, right here in the center. This is the pulsar, the Crab Nebula pulsar. Now, one of the things that HST, Hubble Space Telescope, excels at is looking in the centers of very crowded star fields. We couldn't have done it this well until we fixed it. But looking into the center and finding out individual stars, and you can see it's pretty much at the limit of what it can do here, but you can see individual stars in the center of this. This is called Globular Cluster M13, and it's actually one that you can see fairly soon in the sky in Hercules, in the constellation Hercules. There's 100,000 stars packed into this region, in the central region of this. And this is about 150 light years across in here. So really, really highly packed. Anybody ever read Nightfall? Did they make a movie of that? Yeah. This is Isaac Asimov's Nightfall. I've never seen the movie, but he did do a novelization of it as well, like larger story of it, where people, what would it be like if you lived on the planet in the center or near the center of a globular cluster? You would never see the night sky. There would be so many stars in your sky you would never see it. Was that true? Or, oh no, I know what it was. Yeah. They basically had two stars. It was going around two stars or three stars, and when they all three set once every 10,000 years together, then the people living on that planet would see the stars for the first time. And the thought was it was going to drive them mad. And apparently their civilization had risen and fallen several times over, you know, a million years or something, where they had seen the stars and gone mad, destroyed their cities, and had to start all over again. I don't know how true that would really be. I mean, we seem to be able to create and destroy our own civilizations without this, but anyway, this is so this is a globular cluster. You can think about whether or not you'd like to live on a planet in the middle of that. So this is what HST is. Another thing that is very good. How much time do you have? So here's the heart of this thing. I just basically cut around it so you can see what the heart of it looked like. They took a look at it again, and you can actually see a few more stars in here, zoomed right in there. It's pretty fascinating. All right, so the other thing that HST is really good at looking at are these dim, distant objects. And it gives us great detail in them. So these are galaxies. This is a group of galaxies called Stephan's Quintet. Now, when HST started looking at galaxies, I think we all knew there were a lot of galaxies out there, but HST started showing us that there were way more than we could possibly think of. So it took very large-scale images, which I'll show you in a little bit, and it's been taking very nice images close up or at least very detailed images of these things. So this is a galaxy that I don't think is part of Stephan's Quintet, just happens to be in a line of sight. But you can see all this blue color here. These are all hot young stars that have been born, you know, within the last few billion years. They actually indicate that something happened to this galaxy to spur a lot of star formation. When you see a lot of blue in these, it's basically generating a lot of stars. When galaxies collide, the shocks and stresses that they go through cause clouds of gas and dust to push together, and you'll see these great bursts of star formation. So this is like a little star-birth galaxy. These galaxies are interacting with each other. There's one here, there's two there, there's the third one there. See this blue material coming out here? That's all been pulled off as a result of interacting with us other galaxies over here. So they dance together and they just gravitationally pull the material out. It's like pulling putty or silly putty out. This is all gas and, oops, sorry, I'm back here. This is all gas and dust, and there's stars being born in here as well. There's star formation regions here. You're seeing little, basically little Orion nebulas up in here. Those are all going to be areas that are going to be bright blue in a few million years or so. And there's a little bit of it going on down in here as well. This is a pretty interesting galaxy grouping that they've been studying for quite a while. This is another interacting group called ARP 274. It's a system of 3 galaxies that are colliding together. And you can, again, start seeing the blue spots. This is where star formation is just really being, these galaxies are being riddled with star formation. You don't see a lot of it in the cores. It's really out in the edges where they're interacting with each other. 2 of the 3 galaxies are forming stars at a really high rate. The other one seems to be a little bit lagging on that. And the largest component of star formation is right in the middle here. Kind of see it happening here. So our galaxy is going to collide with the Andromeda galaxy in about 4 to 5 billion years, and it will take some number of billion years for the 2 of them to collide with each other. They'll move apart, they'll dance together, they'll move apart in a gravitational interaction. At the end of that whole process, there will not be a Milky Way or an Andromeda galaxy. There will be a spherical galaxy called Milkdromeda or something like that. That's one of the names they used. But apparently the end state of all of this is an elliptical galaxy. And elliptical galaxies don't really have the rates of star formation that their spirals did. And we're still trying to figure out, when do spirals form, how do they form, what are the influences of them, what's the influence of dark matter, which is a really good question. I had a gentleman, you probably heard this yesterday, I was eating breakfast and Armin Shimmerman was in the room and he asked, what about dark matter? So we talked about dark matter. And dark matter is one of these things we don't know a lot about. We know that it's there. We know that we can detect its gravitational pull on objects and on light as well, but we don't know what it is. And it now turns out that every galaxy is permeated with dark matter, and that dark matter existed at the beginning of the universe. It was probably the formative influence that pushed the early clouds of hydrogen together to form the first stars, and it's continuing to influence the expansion rate of the universe and the formation of galaxies and what goes on in galaxies. We're really starting to understand what it's doing. We just don't know what this stuff is. This galactic mess is called ARP 194. And this is the aftermath of at least 2 galaxies forming. You see the starburst regions here? These are huge regions where starbursts are going on. There's another little galaxy down here. There's a center of one in here, then this one. And it's basically, they're just shredding each other apart. The gravitational influences of each galaxy are, again, pulling out these streams of material. Here, there's a little bit coming out here. So they're really just kind of beating each other up during this giant cosmic dance. And so these are super clusters of hot stars that are being formed. And they'll live about, a few million to 10 million years, something like that, and then they die. They're so massive, they basically live fast, die young, leave a beautiful supernova. So Hubble is surveying the very distant universe as well, and this is what I was talking about before. Nearly every object you see in this picture is a galaxy. There are a few stars here, but those are all galaxies. And every galaxy there has millions or trillions of stars, billions or trillions of stars. And the thing that when I look at an image like this is called a Hubble Deep Field image, that, okay, there can't just be us in the universe. It's the first thing we all think of. It's just a waste of space, as they said in Contact, to have all of this stars and galaxies, and there's only one planet with life. So it's a kind of a philosophical thing that I think about. This is actually showing us a period of time. The farthest, most distant objects, which are some little red objects here. The reddish objects are the oldest, right in here. Those are looking back at about 13 billion years ago. So a little, the universe was only formed about 500 million or so years before that. So they're the youngest galaxies. The big area now in cosmology is, when did the first galaxies start forming? I still want to know, what came first, the galaxies or the stars? And that's kind of an interesting question to debate. So this is the latest and greatest kind of deep image of the Hubble sent us of the galaxies, and it has looked in all kinds of directions and seen these numbers of galaxies in every direction that it can point. The only place where it can't look is what's called the exclusion zone, which is where the plane of our galaxy cuts across and there's gas and dust there, won't let you see anything. But this is, just think about this for a minute, all these different galaxies. You see, oops, come back here. Come back. So you see, there's a little bit of a, what looks like a little spiral here, there's a spiral there, little spirals here. Some of them look a little smeared. And that's because the light from more distant galaxies is passing through galaxy clusters. It's being lensed, it's being distorted by the gravitational pull of all the dark matter, and it's showing you these little smeared out galaxies in here. And so these are actually more distant galaxies that their light is reaching us after it's been distorted by these gravitational lenses. As we find more and more clusters with these gravitational lenses, we can model how much mass it takes to smear those galaxies to look the way that they do, and that helps astronomers figure out how much dark matter was in there to be able to do that. It's kind of a backwards calculation, but that's one of the things that they do. And that's giving them some feel for how much dark matter there is. And you periodically will see in the news, well, scientists have mapped the dark matter. We continue to map it. You know, we had very broad outlines of where it is. Now we're able to kind of move right into these galaxy clusters and take a look and say, we see the light being distorted, we can figure out how much dark matter there is by the distortion. So that's allowing a little bit better pinpointed precision of how much dark matter there is out there. Mind you, we don't know all of it, but we do know that it's out there. We're finding better and better ways to detect its effects. So Hubble is still clicking away. I don't know how many of you pay attention to Hubble news. There's a website called hubblesite.org, which you can go to and see the latest images. This is one that was released last January, and it's the Andromeda Galaxy, which is the closest galaxy, closest spiral galaxy to us in our own cluster. And it's about 2.5 million light years away. This is only about a third of the galaxy, so from the center out here, out to just part of the edge here. You can see all these different stars, you can see clouds of gas and dust. They don't look like much here, but if you were flying through them, they'd be very thick and dark, and this is where stars are forming. So I took a look at that, and I think they're going to be trying to image the rest of it as well. You can actually go out and see this galaxy. I think you can tonight, right? No, it's a little tough. It's easier to find in the fall. But it's near the constellation, between the constellation Andromeda and the constellation Cassiopeia. You can see it with the naked eye if you get away from bright city lights. It's actually it is the most distant thing you can see with your naked eye. And I've always loved this galaxy. Hubble has looked at the center of it. They've been able to deduce that there's at least one and possibly two black holes at the center of this galaxy. Again, studying all the different areas of starburst. Notice all the blue here. So we've got starburst regions that have taken place here. Some of it, it's really hard for me to see the side, but I know that there's a couple of reddish areas in here where stars will be forming, and we'll start to see little blue stars in a few 100,000 years. I see a hand back there.
Yeah, the individual stars we see, are they in our galaxy?
There are a few, but a lot of them are in there in that galaxy. But yeah, some of them are. Yeah, I couldn't tell you exactly which ones, but there are some. Yeah, it's kind of hard. There's really nowhere you can point your telescope in our galaxy and not get a few stars in the way. But a few years ago, I worked on a set of exhibits for the Griffith Observatory in Los Angeles, and we took an image. Well, we didn't take it. The people at the Sam the Ocean Telescope took this. A scientist by the name of George Dorgovsky took an image that if you held your little finger out at arm's length and covered up one little part of the sky, where your little fingernail is, they took a picture of that, and it's in a place called the Coma Cluster. And it's actually through one of the few windows in our galaxy that you can see through and not get too many of our own stars in it. And there are millions of galaxies and quasars and all kinds of stuff in this. And there's just a lot of little galaxies. We put it up on a wall, 150 feet wide and about 75 to 50 feet high. And people can just walk up and touch this wall. It's made out of porcelain and you can clean it off. And they just see galaxies everywhere they look. So I've watched people sit there, they just walk up and they're totally blown away by the immensity of this. They back up, they walk up and look again, and then they back up and they look again. They're really, really fascinated with this. And it really makes you feel very small. It's like, this is just this little bit that your finger covers, and in this galaxy, this region of the sky can just completely dwarf everything we've ever known. Oh yeah, so you can see out to the edge of the galaxy here. Yeah, and some of these stars are ours in our own galaxy. The image covers 62,000 light years of the galaxy, and there are 100 million stars and star clusters and dark lanes in the view. And they're still really studying this image. They gave this to us, and now the scientists have gone back and they're looking at what's going on there. Well, it's been a pretty eventful 25 years for Hubble. I'm hoping that we'll get another 5 to 10 years. what I've showed you here is just sort of a tip of the iceberg of the work that Hubble has done. It has taken us from looking at, and I didn't even show you the planetary images. It's the stunning images of well, except for Saturn, Jupiter, Mars. It's looked at Venus once, which was very difficult for it to do. It cannot look at Mercury. Mercury is too close to the sun. It's looked at all the other outer planets. It's actually looked at Pluto. I think Alan showed you that 9-pixel picture yesterday of Pluto. It is a multi-wavelength machine. It looks at everything in optical and ultraviolet and infrared light. And if everything goes well, it should stay up working until after we launch the James Webb Space Telescope. Now, I know you're going to ask me, when's that? I don't know. Nobody knows. Like, we're looking at the early 2020s probably for that to go up. So this is our grand old man of astronomy. The thing that was a techno turkey 25 years ago is now like the best telescope ever in the world. If you want to see how far it's gone, when you look at a picture from someplace like Gemini Observatory or the Very Large Telescope or whatever, they like to say, well, we're just as good as Hubble. Nobody would have imagined that 25 years ago. We're just as good as Hubble. Or in some cases, they're going, we're better than Hubble. So I mean, there's a lot of that kind of bragging going on. And it is true that because of what Hubble went through, we had to learn new technologies to be able to eke out more information from our images, which have been applied to images from ground-based telescopes as well. We have adaptive optics, which is another thing that people use on ground-based telescopes to sharpen their images, and it's a fairly complex process that they go through using laser guide stars up in the sky, and they then subtract the atmosphere out from the image, and then you get these sharp images. And those guys will tell you, yeah, we have better than Hubble resolution. And then sometimes they do. So Hubble is not going to be surpassed anytime soon except by JWST, but it's up there and it's giving us things that we never imagined we would see in the universe. So, that last one I showed you, that's the website. Go to hubblesite.org. And they will show you all kinds of stuff they have. If you're into homeschooling or you want your kids to learn more about Hubble and science, they have a whole thing for teachers and parents and kids to explore on. And they're going to be doing they are already doing a lot of Hubble hangouts and little videos and things that are basically celebrating the birthday of Hubble. And you can go on there. It has done about 1.25 million to 1.5 million observations in 25 years. So there's a few things on there you can look at. So I want to thank you for coming, and I think I have plenty of time for questions. It's about 1:45 or 3. So I'll pull the lights up, and I'm happy to answer questions. Anybody? Yes?
So how does color correction work with the Hubble? Is it,
Color correction?
yeah, is this, if you were in a spaceship and you were to go and look out a window, would it look as colorful as it does?
No. What they do is, in some cases, so they're shooting through filters, and then they can use those to filter for specific gases or objects or whatever they're looking for. Then the scientists, like some of the images you've seen, the one over there, those are color-coded images. So those are not really what it would look like. So this guy over here in the far left, it's another nebula here. Those are color-coded for the kinds of gases that Hubble is seeing. And I don't know what the coding is, but I'm guessing probably green is oxygen. Probably the blue is hydrogen, and this may be sodium or something like that.
Is there anywhere you can go to find what it would really look like?
You can dig into the raw data all you want. Good luck. So the raw data exists, and it's gone through something called pipeline processing, so they've taken out the worst of the artifacts and glitches and snots and everything that show up. But it's not going to tell you anything. You just have to pull it out. And they really look ugly. I mean, I've seen them, and it really is much better to let the scientists, but you can do that. You can actually go there. I don't know if you can get there from Hubble's site, but if you might be able to. It's basically, if you go to the entrance on their site that says for scientists, I think that would take you to their archives. And they've made the archives, so when a Hubble Space Telescope observation takes place, the data are exclusive to that scientist, I think for several months to a year, depending on what they're doing. Gives them that much time to pull out the data they need. Some scientists will immediately make it public. You know, they do their processing, they put their images in, they make it public and let everybody else play with it. So other scientists don't. Sometimes what they're trying to study takes a long time to tease out. Yes, next to you.
So you were saying you're hoping to get 5 to 10 more years out of Hubble.
Yeah.
Is that due to orbit degrade or hardware?
Well, it's a number of things. I mean, the question is, you know, why are we only going to get 5 to 10 years? You know, bear in mind this was only supposed to be at 10 or 15 years, but we kind of over-engineered. Kind of like curiosity and opportunity. But part of it is there are 3 reaction wheels that keep the space telescope stable in space. They're called the gyros. And if one of those goes, they can still do science. It's just tougher to move the telescope around. If 2 of them go, we have to shut it down. So the last time that they service this, they put in good gyros, and they should go for quite a while. But you never know, maybe a cosmic ray hit or something could take a piece of electronics out. Other instruments could stop working. It could take a meteorite. I mean, but I mean, if all goes well, things should continue working 5 to 10 years. And they're hoping to keep this going because we just don't know when JWST is coming up. Yes?
Speaking of which, what's the likelihood of seeing other planets with its successor, with Hubble's
With
successor?
Hubble? It actually has seen them in the Gliese 160 or something like that. It has seen them, they're little dots. Their planets are really hard to see in visible light because the light of the star washes them out.
Even with the next telescope?
Well, that one, yeah, they will be able to because it'll be infrared capable more than anything else, and then you can start seeing little things that are glowing from the light of their stars. So that'll be a little bit better. It's not launched yet, so we don't know how much better it's going to be. There's actually another another telescope out there called WISE, and I'm sorry I don't remember what the acronym stands for, but it's infrared sensitive and it's found quite a few things. So planets, whatever, out there, asteroids. It's actually a really good asteroid finder. Asteroids glow in the infrared as well. The infrared. Yeah, anybody else? Yes?
What are the practical applications that you sell this to politicians so they pay for the next one Sunday?
Oh yeah, well boy, that's the most practical application to a politician would be to say this is going to provide 50,000 jobs in your district. And even then, that's heavy. I mean, to be serious about this, yeah, part of it is district born. You have to have a politician that understands how important science is. Can we name one that does? Who?
No, they're all lawyers. Yeah.
Well, there's that. I mean, there are a couple of doctors. There's one physicist who's in Congress or the Senate, but there aren't that many. And I studied law for a couple of semesters, and I get that you get focused in law. I mean, that's what you've got to do when you're a lawmaker. But come on, couldn't you take biology or something in college so you at least understand how science works?
Right.
So I think jobs are a big thing, and also if we were still in a space race with the Soviet Union, that would be another way to yank their chains. I'm sorry, I know that sounds really cynical, but it's 25 years I've been watching this happen. Yeah.
Yeah, actually a lot of the imaging technology that was used to correct Hubble is actually used in today's modern medical.
Oh yeah, that's true. And in fact, there are some things like, I know you ladies all have a mammogram every year, right? Or when you're supposed to. Mammography has actually benefited quite a bit from this technology. There's other little things like, I don't know about how many of you have ever had the dreaded thing that you have to have when you turn 50. You probably know what I'm talking about. I had to do one from this end one time. That little camera came from technology that was made for the space program. So they could go down and take a look. They use it for finding ulcers and stuff like that. So, all right, one more question, and I'm going to let Rick take over. Yes?
Do you think there's dark matter in the room with us now, or is it way away from us?
Probably. But it's just I mean, it's in the aggregate, inside of a galaxy, the amount of it would be enough to change motion of the galaxy a little bit. And we know that our galaxy is permeated with it. So yes, probably, but you and I aren't going to detect that. Anyway, well, thank you all for coming, and I'm going to turn this over to Rick Stern.
And welcome back to Area DMG. I am your host, Phil Wesley, the Mile High Mouth, and I'm here at Starfest 2015 with
Carolyn Collins Peterson.
And just in case our YouTube audience may not know who you are and what you do, who are you and what do you do?
Well, I'm a science writer. I studied astronomy at the University of Colorado. I'm a documentary filmmaker. We work on astronomy topics, space science topics. I also blog as the Space Writer online, and I write for space.about.com.
Oh, so why did you start with space? What got you interested in studying space?
Well, it started with my dad when I was about 4 or 5 years old, and there was a launch of an object into space called Sputnik, which was launched by the Soviet Union, which is now Russia. And I heard that name, and I thought it was the coolest name I'd ever heard, and I'm walking all around the house yelling Sputnik all day long. And I finally said, I need to see this thing, so he took me outside. Now, mind you, Sputnik was only about this big around, so you couldn't see it from Earth. But he showed me this thing, probably an airplane. And he said, that's Sputnik, and I was happy. But then after that, he started talking to me about stars. And so as I got older, we got more interested in stars. And then we also went to star movies together, like 2001 and that sort of thing.
I would imagine, though, at that point in time, running around there yelling, Sputnik, 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 you kind of don't want your neighbors to hear that.
Well, we lived on a farm, didn't
Oh,
matter.
okay.
So the sheep might have, been upset, but not me, not the neighbors.
And the cool thing about farms is you can see a lot more stars from
Yeah,
there.
yeah, that was in Boulder. So,
what did you study to go into the profession that you're in?
all right. Well, my first degree is actually in education, so I did elementary education, and then I went back to school to study astronomy. So you take undergraduate classes in astronomy, you take physics. I took chemistry, biology, geology. I really wanted to be a Mars scientist. That was my goal. And then when I got to graduate school, and the person who was paying my tuition basically said, well, you're going to study comets because that's what I'm paying you to study. So I ended up studying comets for several years, and also then was put on his Hubble Space Telescope team. So I was one of the few students on a Space Telescope team. But you do a lot of science, you do a lot of math, there's just no way around that. And you have to be really fascinated, you have to love the universe, you have to love finding out what it is. And maybe when I was about 25 or 30, I realized you got to just be willing to stand in front of the universe, essentially with a naked mind, and go, fill me up with knowledge. And that was really where it came from.
What's odd is that, like, you're a woman in a STEM position, like it's the science, technology, engineering, and manufacturing. What advice would you give to any young ladies who may be watching this who want to get into that field?
Don't let anybody tell you you can't do it. You can do it. It is hard for everybody. I mean, there's nothing easy about learning the math and the science. Some people actually have an affinity for it, and I did for some branches of it, but other times you have to discipline your mind, and that is what everybody has to do. And that's true whether you're a taxi cab driver or an actor or whatever. There's a mental discipline you have to go through. So I just tell people, don't let anybody tell you you can't do it. The only person who really should be able to tell you you can't do it is you, and you had to come to that basically after learning more about yourself. But get out there and learn it because it is fun. And astronomy is a gateway science. Astronomy will take you to physics and chemistry and geology and biology and you name it, it takes you there.
So, you said that you grew up around here in Colorado?
Mm-hmm. Boulder.
Oh, yeah, Boulder, Colorado. So, what do you think of Colorado? And why haven't you moved?
I did move, actually.
Oh, okay.
After I finished graduate school, I moved to Boston. And I was hired by a company called Sky and Telescope, and I was one of their magazine editors for 4 years. And then after that, I worked with them freelance for a while, but my husband and I had our business, and we were growing that. And so we lived in the Boston area for 12 years. We just moved back to Colorado 6 years ago. Boulder I loved because it was my hometown, and it's where our farm was, it's where my grandparents' farm was. Went to the University of Colorado. I come back to Colorado now, and I see it as much more crowded than it used to be when I was here before. Boulder itself is bringing in thousands of jobs from Google, and the traffic is just going crazy. We moved up in the mountains, so we actually are away from all of that. We do have to go to Boulder, go to King Soopers, all that stuff, but Colorado is, in another sense, it is still pretty high-tech in a lot of ways, and so people will come here to do their space-based businesses. We've got Lockmart, I think Sierra Nevada is still in Louisville, and places like that. But it's not quite the same as it was. So, there's this old saying, you can't come home again, and that's really kind of true. Once you've lived in Boston, how do you keep them back in Colorado? There's actually a connection between Boston and Colorado. Colleges recruit in each state. So, here they're going, go to Harvard, and then you go there and they're saying, go to CU. It's really interesting to see that. So, it's my home, though.
So, what do you think of Starfest so far this year?
This is my 14th or 15th year of lecturing at Starfest, speaking at Starfest, and I just love it. I have to admit, I just get such a charge walking down the hallway and seeing all the costumes. And people are so inventive and so creative and expressive with their costumes. Now, I brought Alan Stern here earlier, and he came and talked, and I asked him, what do you think? And he was just like, this is amazing. He's asked if he can come back. So.
Excellent. I think they'd love to have him back.
Oh, I think they would. I've already talked to them about it. So.
And I look forward to, you're doing a panel later today about Hubble?
Tomorrow.
Yep, tomorrow.
Sunday, yeah.
Sunday about Hubble, yeah.
I'm talking about the 25th anniversary of Hubble. It's 25 years ago, the 26th of April, that it was launched into orbit. And so I'm going to basically kind of take a look at my favorite images of it, because everybody has their favorites. So it's taken 1.5 million observations, so there's a few.
Well, before we end tonight, is there anything that you'd like to go ahead and promote or?
Well, I have a book called Astronomy 101, and you're certainly welcome to go buy that. And it's Astronomy 101, and it has a really long title, and I can't remember the rest of the name of it, but it's on Amazon.com, and my name is Carolyn Collins Peterson, and it's a great astronomy book, so go buy it.
Excellent. Thank you so
Sure.
very much for the interview.
Sure.
I've been your host, Hope Wesley, the Mile High Mouth, here at Starfest 2015 with,
Carolyn Collins Peterson.
and you are now caught up.